Hello guys, welcome to the DevSecOps channel. In today's session, we will be learning about the Kubernetes components, and the assumption is you need to have knowledge of the Kubernetes. If not, also no issues. Like you just concentrate on the components which I explained, and it is the basic. I mean, in this session, I will be quickly going through what are all the components and the use cases, and then I'll just show you in the command line CLI where you can see the functions as well. Okay, guys, let us deep dive into the session. So, what is Kubernetes? So, the assumption, as I already told you, is like you should know about the Kubernetes. If not, you just follow my other videos. I have just posted over there. You can just subscribe to my channel as well. You can find a lot of videos over there. And yeah, what is Kubernetes? What is pods? So everything will be there. So right now, I have just created a Kubernetes cluster. It's just a cluster created using kind in my Mac machine. So if I put like kubectl get nodes, I have a single node. So again, if you want to create a Kubernetes cluster using a kind is like a very lightweight, and then you can install in Mac, Windows machine as well. I'll just post in a separate videos for this one. So right now, don't worry about this one. I just post in a separate video. Right now, just concentrate on the various components of the Kubernetes. Okay. So first component, let me just take a screenshot. Okay. So the first component of the Kubernetes, I mean, the Kubernetes architecture is completely consists of a master node and the worker nodes. Master node will be hosting almost all the control plane components. And if you see here, this is the master node here, and this has a lot of components. So API server is one of the components. HCD scheduler control manager is also one of the components. Okay, so we will start one by one. Okay, so if a user wants to like create a pod or if he wants to create a pod in the sense, no, Nginx pod or anything. So the first line of interaction will be like a API server. So this is one of the very important and main component of the Kubernetes cluster. So what does the API server do? It's like the heart of the Kubernetes cluster, and I just posted over here. So no API server is no cluster. So it's the front end facing, and it will be like receives the request from the end user. So the multiple users using a kubectl command, they can just interact with the API server, and it exposes RESTful interface, obviously for the users and administrators as well. Okay, without API server, there is no Kubernetes cluster. Okay, so the another one important thing it take care is the authentication authorization. For instance, there is a user A and a user B. Okay, they want to access the Kubernetes cluster. So authentication meaning like, okay, username and password is verified, and then they are given the access. And but if you want to restrict the access for a specific pods or deployments, yes, that is the authorization. So the Kubernetes API server take care of the authentication and authorization. So, and also it also coordinates all operation inside the cluster. Okay, so you can imagine this my cluster I have already created. So when I issue a kubectl, right? So kubectl get pods, right? The first command whenever I issue, right, this kubectl will interact with the kube API server. Okay, in my Kubernetes cluster, I can show you the Kube API server where it is. It's a kind cluster. Okay, it's not a full-fledged cluster, but just understand the functionality. So all the control system planes, right? All the control system components will be in a kube-system namespace. And if you see, this is the API server, as I already told you. Like it will be like an API server. It's if I say like a API server, it's one of a pods, okay, running. So if you see here, it's running as a pods, right? So this server is responsible for authentication, authorization, and also the coordination with the different components. Okay, that's what I just want to share over here. Okay, so the first layer kubectl apply, whenever I issue a kubectl apply, it just comes to this the screen. I mean, it comes to this API server, and from there the request is passed to using the manifest, the request is passed. Okay, so this is the Kube API server, so it handles the request from the user. And then, okay, if I want to create one pod, right, so this master node has another one component name as a scheduler. Okay, so scheduler continuously watches the worker nodes. In this case, node 1 is one worker and node 2 is another worker. And scheduler, if in case this scheduler will just monitor all the nodes, and whichever node is available for scheduling, right? Scheduling, there is an algorithm for scheduling the pods. So everything, no, there is an algorithm over here, and then the available node. Okay, in case a node 1 is available, scheduler will that schedule the pods to that node 1. Okay, if node 1 is like not available or overloaded with other pods, yes, node 2 will be allocated. So scheduler is another one very important component you need to understand. So if you can see here, the scheduler is another one important component. What it does is like it assigns the pods to the most appropriate nodes, continuously monitor the API server. Okay, so this both two functions it has. Okay, then what is the purpose of the HCD? Another one very important part of this component, part of the Kubernetes cluster, is the HCD for in case, right? This is my command line. So if I want to create one pod, right? So what I'll do, Kubectl. If I want to run one nginx pod, Kubectl run run. I can give any name. Okay, nginx demo image nginx, right? So what it will do, Kubectl, yes, obviously it will contact the API server, it will pull down this image, okay, and then it will run the pod, right? So if I run this one, yes, pod nginx demo created. Okay, so you can, I've just used K for alias for Kubectl, so no issues. Kubectl get pod. See, this pod I already created. Okay, so it has been deployed over here, and you can see the pod has been created. And then so all the get commands, whatever I say, issue, right? So once the pod has been created, the pod data is being stored in the HCD server. HCD, you can imagine like a RAM or a memory interface, where whenever you want to retrieve any data or reference for the Kubernetes cluster, right? Almost all references will be inside the HCD server. So whenever you issue a get command or any like what are all, see all the data, whatever you see here, right? So this needs to be in a database, right? So obviously HCD is one of the database and it's one of the very important component. Without this one, no reliability will be there. Okay. So long-term memory, yes, of course. Single source of truth. Since if I have created a pod, right? So how do I know the pod is created, right? So kubectl get command is there, right? So what are all the data available in the database? HCD, the data is available over here. Okay, then you can imagine, then another when important component is a control manager. So control manager is nothing but like there are a lot of controllers. Okay, lot of controllers in Kubernetes, like a namespace controller which takes care of the namespace, and replications controller which take care of number of replicas of the pods. Okay, lot of controllers are there. Everything, all thing are packaged into the controller manager. Okay, so I can just show you like how the controller manager will be there. Kubectl, I have K9s. Okay, you can install K9s, so it will be like a UI interface where you can just go navigate over here, and then you can view the logs and everything. Okay, here I just show you the controller. See, it's a controller manager. If I press L, logs will be here. I mean, it's like a lot of controllers, right? Will be like put in and package in a controller manager. Okay, that is another one important part of a controller manager. Then comes a very important part. Okay, if I run a kubectl run command again, it will first go to the API server, and then it will just go to the scheduler, and then it will check, it is assigned to a node, right? So once the control is passed to the node, right, then kubelet is the captain of this node, or the captain of the ship, you can say. Okay, each node will have must have a kubelet. Okay, kubelet, the responsibility, okay, the kubelet responsibility is that it needs to ensure at any point of time the pod should be up and running, or even the containers inside the pod, right? It should be up and running. So that is the reason this kubelet is a very, very important component. You can imagine as a node agent. Okay. So what are all the steps it do? What kubelet it does? Okay. Once it receives the manifest, it passes that to the container D. Okay. Container D is another one very important component for in case. See, I have issued I issued a command before. This command I have issued it. Okay, what it will do? It will create this pod with the help of this image, right? Image Nginx comes from the Docker app. So who will download this image? Which component will be downloading this image? Yes, this is the container runtime or the container D. See, container runtime can be a Docker container runtime, or lot of container runtimes are there. Here we are using, I just mentioned like Cryo. Cryo is also another one container runtime. Any whichever container runtime you use, the functions are same. Okay, what it will do? It will pull the image, container image for you. In this case, it will pull the Nginx image from the Docker app, right? Then what it will do? Prepare the container root file system, meaning that, okay, this pod should be created, right? So this pod should be created, right? So how do you create this pod? This is a like a Nginx demo. It's made up of a Linux pod, right? So it should create a Linux process or a pod, right? Pod is like a process, okay? So it prepares the root file system of this pod, okay? Containers, okay? Then finally, no, see, this is also another important component. This comes in a Linux operating system layer, okay? All these things. Okay, it will comes in a Linux operating system layer. So once the kubelet passes to the container runtime, the container runtime do these tasks. Yes, fine. Then finally, no, obviously you need to create the container, right? Creation is by another one process name as a RunC. So guys, if your RunC is mostly, if you're a Linux guy, no, you should be able to know about the RunC, but it's fine. RunC you can understand. You can just go. I'll just explain you what is the RunC over here. Okay, so use Linux namespace. Okay, RunC uses Linux components like a Linux namespace and CGroups to isolate the container resources. Okay, in Linux there is a concept like the process isolation. Okay, there are two processes there. You need to isolate the process, meaning that each process will be having a separate host name, user ID, group ID, okay, and the IP address, right? So it's like a process isolation concept, okay? So Linux namespaces. So RunC with help of the Linux namespaces, it will create the pod, okay? So the pod will be created, okay? Pod is created, yes, fine. Yes, it's created. Then what's the next step? I need to assign the IP address of the pod, right? So that's where the container networking plugin is in use. Okay, mandatorily there should be like a, say for example, a pod is created, meaning that you should have an IP address to the pod, right? So you can get this one like get pods -o wide. You can see this is an IP address, like see Nginx demo. This is one of the IP address. Who will assign this IP address of the pod? Yes, it should be like a container runtime network interface, right? So the network interface is the component which will help in the assigning the pod IP address, right? So here I'll show you which in kind cluster that is a daemon set. So this one kind net, right? This is one of the network interface, okay? But the standard ones are like Calico, Flannel and all, okay? So don't worry about like kindnet, because since I just installed in my local Mac machine, you can see the kindnet over here. Then finally, okay, pod has been created and you need to assign the DNS name. I mean, you need to assign the pod DNS, right? Pod name, right? Yes, the DNS name can be assigned using a DNS service, okay? So what is the DNS service over here? I can show you. I can go to the K8s, okay, and then kube-system, and you can see the CoreDNS service, okay, DNS, okay, all the DNS resolution, everything, right? It will take care, okay? So this is the another one function, okay? Then finally the pod is created, because see, I have created this demo pod. Where is the demo pod? I have created this demo pod and it was pretty much quick, right? background, all these things needs to be happen in order to create this pod. Okay, so that is the reason you need to, it's a very important concept. Okay, so again I will reply, again I will just quickly go through. Okay, once the pod manifest is ready and the user interacts with the API server, the API server just check the scheduler just schedules the pod, schedules the pod to the node, the availability to the schedules the pod to the node whichever is available. Okay, so that's the function of the scheduler. Once the scheduler schedules the nodes to the node 1, pod to the node 1, yes, kubelets take the control. Okay, finally kubelet, see, all these components are in control of the kubelet. Okay, everything the kubelet handles. Okay, everything the kubelet handles, and then it will pass the content to the container D. Container D is a mandatory thing to pull the container image, because without container image pod can't run, right? Correct. So then it will pass to the RunC. RunC is like a interface with the Linux kernel to create the pod. Here only the actual pod creation happens in the kernel layer. Okay, kernel layer, and the pod IP address is assigned, and then the DNS configuration is assigned. Okay, so this is the very important thing you need to understand. And I just want to show you like okay, so the kubelet register nodes I told you before. See, already I told you, like, kubelet is a node agent, right? So it will transform the manifest whatever you give to a container D in an OCA runtime spec. Okay, so the container D will be translating this to a runtime spec, right? This format to this format, and then RunC. RunC is the guy which creates the pod. Okay, so RunC makes use of a Linux namespaces. Okay, I already told you Linux namespaces is that. What is a Linux namespace? Yes, a kernel level feature that provides a process isolation. Okay, each namespace give a process separate view of system resource. I will just show you what does mean. Okay, so there is a, I'll just show you here. We have already created one pod, Nginx demo. I can just go here. I can put a shell command. I can put like this one. See, if I put process, I have logged inside the container. Okay, Nginx deployment container, and if I put a process, it has a root process of process ID 1, right? Some Nginx process is running. Okay, in this cluster, that I have another one server like Ubuntu. I'll just show this one. Ubuntu. I'll go into the smin shell. I'm just going into the shell. If I put a process -axe, here also the process ID is there, but it's like isolated for this process or this container, Ubuntu container, right? So here the process ID 1 is like a different command or a different process is running, and for here the process ID is like an Nginx is running, right? So these two things are different. Okay, so that's the isolation it will provide. Who will provide the isolation? Linux namespaces provides the isolation. Okay, each namespace or each process ID, CPU and memory, everything will be isolated for this container. Okay, and also there is another concept like a C group. So what is a C group? For instance, I am running a pod. No, it should not consume almost all the CPU and memory for the of the host system, right? This should be avoided. So in order for that, C groups will be limiting the limit. For instance, now if I set like a limit like a 2 GB, yes, the process will be killed after this, once this 2 GB is reached. Okay, so that is the main thing you need to understand. Yeah, this is a very interesting topic, and I have just written down what are all the steps over here. So first step, kubelet. Inside, once it enters the kubelet, all the step by step I have just inserted over here, like Linux namespaces, and finally the pod is created. Okay, so please do subscribe my channel, and I will be posting a lot of videos, or I already posted a lot of videos related to Kubernetes. So please do subscribe my channel, and see you in the next session. Thank you.